Okay, so we've got our uniform rods. It's a smooth horizontal surface, so therefore we'll just have a normal contact force up there. We're going to call that A, and normal contact force up there, C. Let's put the weights in here already. It's got a string attached here, so there'll be a tension going across there and a tension there. They're both equal and opposite there. And that's it. So, by considering the equilibrium of the whole body, it even tells me what to do. Show the force acting on B, C, at C. So I've got to find this one. I'll show this 1.75 W. Okay, well, in order to do that, I'm going to take moments about A. So, part 1, take moments about A for whole. And as always, I'm putting anti-clockwise equaling clockwise. And what goes anti-clockwise? Well, it's this T bit, this C bit. So it's C times by the distance of away from the point here, the line of action. So it's 4, that's 4L cos 60, and that's 4L cos 60. So it's 2 times 4L cos 60. Nothing else anti-clockwise, so that must equal this W times by the distance, and the distance of the line of action of this comes down to here, so we're looking at that, which is 2L cos 60, 2L cos 60, plus this 2W, and that is times by the 4L cos 60, which takes me up to halfway, and then I've got to go another 2L cos 60. First thing obviously I can do, I can cancel out the L's, divide everything through by L, and cos 60 is a half, so that's 8 times a half, so that's 4C equals W times, that's just W, plus 2W times by half of 4 is 2, plus a half of 2 is 1, so 2 is 3. So it's 6W, 7W, so 4C equals 7W, so C equals, divide by 4, 7 over 4W, which equals 1.75 W. So I've done that bit, and find the force acting on AB at A. Well, I can just resolve upwards, and I get A plus that 1.75 W equals the bits coming down, W plus 2W. So that means that A is 3W minus 1 3/4. That's 1.25 W. So it's done the whole of the first bit. The second bit, I'll do it up here. We've got to find the tension in the string in terms of W. When to find tension in the string, these are internal forces if I consider the whole object, so I'm going to have to either consider AB or BC. And I'm going to consider BC because I know they told me that C is 1.75, and I could have made a mistake. So I'm going to take moments about B, because it's got forces here, I don't know actually what they are. So moments about B for BC. And it's always nice showing what I'm doing. So I've got anti-clockwise equals clockwise, and what have we got? We've got the 1.75. So 1.75 W times by, and it's this distance here, so that'll be 4L cos 60. And there's nothing else going anti-clockwise. I've got 2W, so that equals 2W, and that will distance, dot that up to here, that's the distance we're talking about, which will be 2L cos 60. And then I've finally got this T plus T, and that's 60, so this angle here is 30, so it's T, and I want this vertical distance here, that'll be L cos 30 times L cos 30. So what have I got? Well, obviously I can get rid of the L's to start off with, divide everything through by L, and that will give me 1.75 plus, no, times rather, that's a times, that's going to be 2, that's half times 4, 2, so it'll be 3.5W equals 2W, because cos 60 times 2 is half times 2, so that was 1, 2W plus cos 30 is root 3 over 2, so root 3 over 2t, so that gives me root 3 over 2t equals 1.5W, so root 3t equals 3W, and divide both sides by square root of 3, and so 3 divided by square root of 3 is by definition square root of 3, and so that's what t equals. That's done part 2, and finally part 3 I'll do down here. Don't think I do very much. I need to find the horizontal and vertical components of the force on AB at B. So if I draw my AB, like so, I'll put the forces in there. A goes straight up there, that goes down there. Tension is equal and opposite tension, so that goes root 3W there. And I've got to work out what happens at the top. So pretty obvious, well, that's W, and that's 1.25 W. So if we resolve horizontally, I've got root 3W going to the right up here, so obviously it's going to have to be root 3W to left. And that will stop it going, accelerating to the right. And then we've got to resolve vertically. At the moment I've got 0.25 going, 1.25 going up, 1 going down. So this is going to have a force of 0.25 W down. So yeah, 0.25 W down, and that's pretty easy for 3 marks. Actually, the whole question's pretty easy because it told me what to do. That's question 5 done.